All right, let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1203. Well, sort of the last edition, if we can call it that. Supposed to be giving you info on the final today, so let's actually start that. Boom, boom, boom. Okay, so how the review is going to work, it's going to be, for the most part, self-directed by you guys. I am going to make some general comments about what I think is important, and then I'll open up for maybe like a Q&A in case you guys want to ask anything, have any questions, comments, concerns. So let's actually jump into that. So finals this week. One of the finals is on Saturday, which is weird, but that's what it is. I didn't choose the final exam schedule. So if you're in section LO1, so you're in the section that meets with me twice per week on Mondays and Thursdays, your final is on Saturday at 9:30 a.m. It'll be on Gradescope. It'll be kind of the same deal with when you're taking tests, but it'll just be longer. It'll be about twice as long as a test. And so the other section, the one that meets with me Tuesday, Wednesday, Friday, that final is on Thursday at 1:30 p.m. So make sure you know that. Make sure also that you double check the final exam schedule. Triple check. This in your other classes, be sure to do that. Always keep checking, making sure that you have the right information, make sure that Jhevon didn't make a typo. How do you know that I didn't make a typo, right? You can't blindly trust me for everything. Okay, so, but that, as far as I know, is when your finals are happening. All right, so in terms of the format, what the final is gonna be like, I just made some comments here about what I wanted to say, as well as talk about where you could get some practice problems, I guess, on some of the later stuff. So the final is going to be essentially a combination of test 1 and test 2. That's what it's going to be, right? So you think of test 1 and test 2, you smush them together, you get the final. That's pretty much it. So the final is going to be about 2 hours long, plus upload time, maybe 2 hours and change. Sometimes I make it, I give people an extra 15 minutes. I would say 2 hours and 15 minutes plus upload time. But you'll know that time prior. But just expect 2 hours plus upload times of say 15 to 20 minutes. And like I said, it's going to be like a combination of test 1 and test 2. To be a little bit more specific, a bonus problem like the bonus 2 on test 2 will actually be moved up to the actual final. So that was a problem where I asked you, oh, find the area under this curve, the exact area under this curve. So a problem like that is not going to be in the bonus, it's going to be in the actual final. Bonus 1, part 1, problems like that will remain in the bonus section. The other integration problems, you should actually be able to do them because you're just applying direct integration rules without needing anything sophisticated like substitution. And in lieu of bonus 2, so like I said, you can imagine the bonus section for the final is going to not have anything like bonus 2, but in lieu of that is going to be an area between curves problem, right? So I'm going to give you 2 curves and you have to find the area in between them, right? Which is, if you know how to find the area under one curve, the area in between them isn't going to be that bad. It's just like you integrate a subtraction, which was, that was done in the asynchronous lecture, which I didn't post yet because technical issues. As you might notice, I'm in a different location and everything. Yeah, other than that, what would be covered in the asynchronous lecture is going to be bonus material anyway. So I'm not going to strictly hold any of that against you, especially since at this point I would have posted it a couple days late. But yeah, so that's essentially what the final is going to look like. Mash together test 1 and test 2. The bonus section is going to be integration by substitution and error between curves. Everything else that I spoke about, you're responsible for. So yeah, that's what it'll look like. It'll have about 16 problems, including the bonus problems. Yeah, I mentioned here that it's not going to count the asynchronous. So yeah, to be a little bit even more specific, the final covers everything up to fundamental theorem of calculus and using it to find the area under curves. Whatever comes after that is bonus, right? Which is what the asynchronous lecture is about. Mentioned there, 2 hours plus additional upload time. Use your smartphones. I've heard people choosing these very inefficient roundabout ways to upload your answers. Log into Gradescope on your smartphone, take a picture and just upload right away. I mean, that's the quickest. It'll almost take you no time to upload other than the last question. You can upload a question while you're working on another question. And then at the end of the upload period, you'd only have one thing to upload. You'll have all the time in the world. You can even use extra time to work on the test. Why would you not do that? I've seen people like, oh, I have to transfer this to my Windows computer over here. I have to print this out and then I have to scan it and then I have to download it and then upload it. Like, what are you doing? Take a picture with your phone, upload it from your phone. 3 seconds. Okay. Yeah, so upload time, if you play your cards right, could be extra test time. I don't understand why people decide to not do that. You know what? Let me take as much of this upload time uploading as possible. Okay.
Also, I realized though, you have to log on first, like start the test from your phone.
Right.
Yeah.
But then subsequently you can log on to it on your computer if you want to read it from a big screen.
Yeah.
Yes. So the source you want to upload from, you should log into there first, because otherwise it's going to force you to switch sources. You have to like refresh the page and some other stuff. It's not gonna work. So you'd log into your phone first, and then you can log into on your laptop or your desktop or whatever to read the questions from. But you actually do the uploading from your phone. Yeah, what else? I'm not really going to give you a mock final. I think the description is enough. However, there is a final exam from spring 2019 that was posted. And I think that would be very good practice. It's just that you can just imagine in that final, problems like problem 2A and problem 10 would be in a bonus section. Also, I guess something that's a little bit different from that final is that on the file that you're having, I might have one of those questions, because it's on a computer, where I give you a picture and I ask you some questions about the picture, which I usually don't do on a written final. So yeah, so that's gonna be it. So spring 2019 final is still pretty good practice, I think. Just know to actually skip that last question. So as far as more practice is concerned, especially with the last leg of the course, there's also an integration worksheet. If you scroll all the way down to the bottom of the page, that can give you some integration practice. And I mentioned here what problems will account for real practice versus what problems you can think of as, that's bonus material. So technically I don't need to know this, but if I can know it, it's just extra points for me. And I'll use the extra upload time to do the bonus problems instead. So yeah, maybe in terms, yeah, I did that. Okay, so this is the class webpage. If you scroll all the way down, yeah, so like right here, you'll see the spring 2019 final. So there's an example problems. You can print those out. You can do them. A problem like that, you would need integration by substitution to do. So I would ignore it. This you don't. This you don't. This you don't. By the way, for those 3 problems, I had students in spring 2019 trying to do substitution on all of them. It totally wasn't necessary. It's just a trick. Well, it's not really a trick. I mean, I told them when it would be necessary from when it wouldn't. So there's a problem, that's all normal, that's all normal, that's all normal, that's all normal, that's fine. That's fine, that's fine. That's fine, that's marginal functions. Yeah, so like problem 10, we're asking you to sketch these 2 curves and find the area between them. Like that would be a bonus. And what's going on here? Is that in my browser? Why is my browser trying to get me to get into Bitcoin? So yeah, so that and problem 2a, you can imagine as a bonus, and other problems like problem 2a. So you can just look in the integration by substitution section or practice some of those integration problems that I mentioned for more practice on the integration. So the integration worksheet is all the way at the bottom. So there they are, some more practice problems there. So like I said, in problem 1, you should be able to, at this point, do part A, C, E, F, G, H. Yeah, the others you would need substitution for. You can do all of problem 2. And for problems 3 and 4, those would be bonus, right? Which I already said that in the thing. Okay. So you have a bunch of practice problems there. We also had handouts where, related rates, where you can practice those again. And some marginal functions, exponential. So you have handouts where you can practice problems from. We did a lot of examples in class. You can practice problems from the old tests. So like you might go over test 1. It's very possible that you guys forgot specifically what was on test 1 at this point. So you can go there and it won't be like you're doing something you already did. You totally forget it by this point. So you have a lot of places you can practice. But yeah, so that's kind of what the final is going to be like. Test 1 and 2 match together. Bonus section is on integration by substitution and area between curves. Everything before that, you're responsible for in the actual final. And of course, the typical problems. I'm going to ask you to differentiate stuff. I'm going to ask you to find a tangent line. I'm going to ask you to sketch a curve and find concavity and stuff. I'm going to ask you to find absolute extrema, do a related rates problem, do an optimization problem, do an exponential growth or decay problem, do a marginal functions problem, do some Riemann sums problem, errors between errors under curves. Yeah, just the typical stuff. Shouldn't be a surprise. Nothing should be a surprise on the test. Right? So, I mean, if you go into the test and you're like, what? This is on here? It means you didn't study enough, because it should be obvious that that would be on there. So yeah, that's essentially what I wanted to say. I also want to say that you guys should be using the regrade request features. Okay, so you have an issue on a quiz or a test, you should submit a regrade request for the problem. So there were problems, especially on the last quiz, where if you didn't type in the answer correctly, you might have typed the right answer, but because you had spacing, or maybe you didn't use the right symbol or something, it would have marked you incorrect. Like things like that. Don't just email and tell me, oh, I think I should have got a bunch of these problems correct. No, it's not helpful. Click on the problem that you think you deserve the right answer for, send in a regrade request. That will alert me in Gradescope when I need to look at something, and I can just deal with it right there. So be sure to use that. So I don't have to be guessing as to what, I don't want to have to go over everyone's problem and grade it all manually. Just tell me which specific ones there are, so can be more efficient. Okay. Yeah, so that's when the finals is. That's what it's going to be like. This is where you can get more practice on the last few topics. Submit your really good requests. And at the moment, right now, any other questions, concerns, comments, questions? You can ask me questions about specific problems, questions about maybe a strategy for a certain problem, questions about general questions about the final or the class.
I have a question.
Yep.
Would you be able to go over a couple of like the integral problems? Like there's one that I was
Sure.
working on like not too long ago in the homework.
Sure.
Yeah, I can like
Yeah, so you'd have to tell me what
yeah.
they're.
So it's like the little like SF thing, and it's 0 and -1.
-1 here and 0 up
Yeah,
there.
yeah, and then it's x squared minus e to the x.
Like that?
Yeah.
So this one, again, it's going to be one of those ones where you have a straightforward formula for. So the strategy for these is you need to know the formulas. There are 3 or 4, depending on how you look at it. I remember 3. But it's going to be, if you have antiderivative of x to the n, that gives you x to the n plus 1 over n plus 1 plus c. That's if your n is not equal to -1. Another formula you would know is if you want to integrate 1 over x, that is ln of absolute value of x plus c. Another formula you should know is if you want e to the kx, this is 1 over k e to the kx plus c. And this one sort of implies that the integral of e to the x dx is e to the x plus c. Right, so you'd know those formulas first. Also know this side over here is the side that we call the general antiderivative. You think of that as big f of x plus c. Right, so you always have like the integral of little f of x dx is equal to big f of x plus c. So the right sides of these equations is the big F. Now, what that leads to is something called the fundamental theorem of calculus, which tells you if you have an integral with numbers on it, like an a to the b of little f of x dx, that is actually equal to your big F of x between a and b, which you take the top number, you plug it in, subtract the bottom number, and you plug it in. And that will be your answer. So with that being said, knowing those 2 main facts, which for the shortcut for integration, that's all you would need to know. Well, you would also need to know that what this gives you is the net area under the curve. Okay, which is like the area between the curve and the x-axis. If the curve is underneath the x-axis, it gives you a negative area. If the curve is above the x-axis, it gives you a positive area. And if the curve does both, it'll give you a negative and a positive, and they might cancel each other out to some degree. Okay, so that's the interpretation of this guy. So if I ask you for the area under a curve between this point and that point, you should use this formula. Okay, now knowing that is going to help you here, because now you see like this guy looks like an x to the n, it's x to the 2. So you're going to add 1 to the power, divide by the new power. So this guy is going to become x cubed over 3. Then the e to the x, you have this rule right here. That's just going to be e to the x. Now, when you have numbers on it, you don't need the plus c. You just have this bar here. You write the numbers like so. And that is your cue to take the top number and plug into the function, and then subtract the bottom number plugged into the function. So I'm going to take 0, plug in for x, minus, I'm going to take -1 and plug in for x. And so that's going to be -1 minus, well, it's going to be +1/3 plus e to the -1. So that's going to be e to the -1 minus 2/3. Okay, so to get rid of the integration sign, you apply these rules. And then if there are numbers on the integral sign, you take the top number, you plug into the formula, subtract, open parentheses in case you have to like distribute, and then plug in the bottom number into that formula. And that computes it. If there were no numbers on the integral sign, then you would actually just leave it with a +c. So if instead it was just integral of x squared minus e to the x, then add 1 to the power, divide by the new power, that's e to the x, and then you put a +c. And that would be the answer.
So I had gotten that answer, but when I plugged it in like online, it came out wrong.
Make sure you're plugging it in correctly. So this is a situation where if you're not using the parentheses in the right place or something. Like, how did you type this in?
Like how you put it just there. I think I had like -2/3 plus e to the -1.
I don't know, that should be fine.
It said it was wrong, so I don't know.
No, that should be the right answer. Maybe you should let me know what's going on with that problem. Sometimes the problem also might say, there's a very common notation when typing out E, and it's the EXP notation. So make sure you check the instructions and it didn't say something like that. So e to the x is sometimes typed out as exp of x. So it might have wanted that, which is possible. So when you want to type e to the -1, you can type exp -1. That might be something. And you mean you used the template and it looked exactly like this, or did you use caret?
No, like I wrote it exactly like this, but I think I actually just found the problem. It's 2x minus e to the x, not x squared. So sorry about that. Never mind.
Huh?
I wrote the problem completely wrong. I
Oh,
put
the original problem was
the
wrong.
actual
Yeah,
problem's 2x,
that
not
that
x squared.
that happens. That happens
Yeah.
a lot. You should always check that too. So with 2x minus e to the x,
Yeah.
yeah, the same idea would work. So this is -1 to 0. You just think of this as x to the first power. And so you add 1 to the power, divide by the new power. So the 2's would cancel. And so you plug in the 0, minus, you plug in the -1. Well, that's just -1. Yeah, so that would be -1, -1, plus e to the, so you'd have e to the -1 minus 2. So if you have x to some power, it will, you just add 1 to the power, divide by the new power. That's called the antiderivative. If there are no numbers on the integral sign, just put a +c. If there are numbers, you take the top number, plug it in, minus bottom number, plug it in. Also, just know that the integral of say a constant, is just going to be the constant times the variable plus c. And this is just, it's kind of an in particular thing. Now, there are a couple ways for you to know that. So just know that if you differentiate a constant times x, you just get the constant. Another way is to realize that having a constant is the same as having a constant times x to the 0. So you would add 1 to the power, divide by the new power plus c. So you get the kx that way. It's the same thing. So if you have a constant, just know that you just add the variable to it, x. You add whatever variable is here. So if I were to say something like the integral of a constant dy, then that's going to be ky plus c. The rules still apply. X is just a dummy variable. It's a placeholder. You can have any variable there you want. Or if I have integral k dt, and this is kt plus c. Okay. Other questions?
I have another problem that I'd want to go over.
Oh, yeah, sure.
If that's okay, I guess no one's speaking now. It was one of the like division ones where you have like a polynomial like over a number. So this one was the integral with between 2 and 1, or on 2 and 1. I don't know how you'd say that. And it's x to the third plus 9x to the sixth over x to the fourth.
So here you would simplify. X to the third over x to the fourth plus 9x to the sixth over x to the fourth. So that's just 1 over x plus 9x squared. And then for the 1 over x, you know the rules. They're up here. It's going to be ln. Oh, right? And then for the x squared, it's the first rule. So yeah, so this is going to be ln of absolute value of x plus 9x cubed over 3 between 1 and 2. So that's just ln of absolute value of x plus 3x cubed between 1 and 2. So you plug in the 2, minus, plug in the 1. Absolute value of 2 is just 2, so you can remove the absolute values there. 2 cubed is 8 times 3, that's 24. ln of 1 is 0. And then here I would have minus 3. Right. And by the way, this is another way this could have been phrased is this is the area under the curve y equals on the interval 1, 2. right? So if you have this guy of 1, 2, and you have your, whatever that curve looks like. So this is your f of x equals x cubed plus 9x to the 6 over x to the 4th. Then the area under that curve is 21 plus ln 2. So the question could have been asked in that format as well. Find the area under f of x equals blah on the interval 1 to 2, and you would do this.
I had a limit question.
Sure.
It's the limit as x approaches 1 from the right, and then in parentheses 1 over ln x minus 1 over x minus 1.
Is that a separate term?
Yeah, it's 1 over ln x minus, x minus 1.
Yeah.
Yep.
Okay, so if you're approaching 1 from the right of ln, notice that this is going to give you negative infinity. So it's 1 over negative infinity. That's going to go. We're approaching 1 from the right. So that's approaching 0 from the right. So this is going to be like a positive infinity. Minus, if x approaches 1 from the right of that, it's also going to be positive infinity. So it's infinity minus infinity, it's indeterminate. Because it's indeterminate, we now need to kind of do something to simplify it, perhaps using L'Hopital's rule, but perhaps after simplifying, we won't need to. But L'Hopital's rule should be what I'm starting to think here. So once it's indeterminate, you should start to consider L'Hopital's rule. Which means you would need one fraction, Right, because L'Hopital's rule tells you to find the limit of f of x over g of x, not like a difference of two things. So the first thing I would do is to combine this into one fraction. Which you can get as x minus 1 minus ln x all over ln x times x minus 1. Right. And of course, that's because we know that a over b plus c over d is just going to be ad plus bc over bd. And you do the cross multiplication thing and multiply the denominators, get a new denominator. Okay, so now we have one fraction, and you will see that this guy will go to, if your x is approaching 1, x minus 1 is approaching 0, log of 1 is approaching 0, so you have 0 in the top. If your x is approaching 1, log of 1 approaches 0, and x minus 1 approaches 0, so you have 0 in the bottom, which means L'Hopital's rule applies. And so here I can apply L'Hopital's rule. L'Hopital's rule says this limit, if it exists, will be the same as if I differentiated the top and the bottom, so that's what I'm going to do. Derivative of the top is going to be 1 minus 1 over x. Derivative of the bottom by the product rule is going to be 1 over x times x minus 1 plus ln x. See where this goes. If I plug in 1, I get 0 on top. Plug in 1 again, I get 0 on the bottom. I would try to simplify though, to make sure I don't need L'Hopital's again. So I can multiply by x over x. This will give me x minus 1 plus x ln x. Yeah, that still approaches 0 over 0. So I'll hit it with L'Hopital's again. Derivative of the top is 1, derivative of bottom is 1 plus ln x plus 1. And now let x approaches 1. Log of 1 is 0, so you would get a half.
Thank you.
Right, so you kind of just test where the limit's going to go. You'll realize you get infinity minus infinity. This is indeterminate. There's 7 indeterminate forms, which you should know what those are. And once it hits indeterminate, what you're going to do is you're going to try to think, oh, how can I get L'Hopital's rule in here? And essentially what that means is you're going to have to make things look like one big fraction. And so things like combining them to get a fraction can work. Another situation is if you get an indeterminate form where it's in the form of an exponential, like it's something to a power, in which case rewriting it in terms of e to the ln of the thing can work. So we have that basic example of something like limit as x approaches 0 from the right of x to the x. Right, so that approaches 0 to the 0, which is indeterminate. And so what you can do is write this as e to the ln of that thing. And so you have e to the x ln x. And then looking at the power, you realize that that goes from 0 times infinity, which is again indeterminate. So now you want to think L'Hopital's, but it's not in the right form. You need to get it to look like a fraction, and you can get a product to look like a fraction by just turning one guy into the reciprocal and moving him underneath. So I can write this as ln x divided by 1 over x, because 1 over x is x. And so now I look at the power. As I approach 0 from the right, log goes to negative infinity. As I approach 0 from the right, this goes to positive infinity. You have infinity over infinity. So you know L'Hopital's applies. And so I can apply L'Hopital's by differentiating the top over differentiating the bottom. I would simplify, that leaves me with negative x in the top, and then x approaches 0. So that limit is 1. So these are some tricks you should just make sure that you know. Know when you should use L'Hopital's rule. What do you have to see to know that it would apply? Then you would know all the ways to get into the right form. So if you have something to a power, e to the ln maneuver usually works. If you have a product, then turning one thing into the reciprocal and moving it in on the bottom usually works. If you have 2 separate terms, combining them into one big term usually works. Yeah, those are most of the cases that I might have been forgetting some, but it's all in the notes somewhere. You should also just know about limits in general. You face with a random limit, what do? You try to plug in. That doesn't work, try to simplify so you can plug in. If that doesn't work, you might think of the graph if it's easy to do. It might be a special situation where it's like a ratio of polynomials and you're heading off to x approaches infinity, in which case you can see if it's top heavy, bottom heavy, or ratio of coefficients. Or it's something else that's totally crazy and none of these other things can work. And then it's probably L'Hopital's rule, unless you can simplify it to look like something else.
Yeah, Professor. I just had a general question about the regrade requests.
Yes.
Because I've never really utilized it like throughout the semester. So I was just wondering, do you have like a limit on how far back you're gonna be like accepting regrade requests?
Normally I wouldn't take anything beyond that came before test 1, but I guess no, just submit everything.
All right, thank you.
I guess something else general that I would say is in terms of like what should happen, and I guess I'll send out an email about this as well, but in terms of what happens after you take the final, so I expect to finish grading it within a week, and at that point I will release the file to you in Gradescope so you can look it over. I will also update your report card in Jupyter and send those out. And the moment that I send those out, so you'll know what grade you're supposed to get or what grade I would give you. So I'll put a comment on the grade I'm intending to give you because it might actually be different from the actual grade that you get. So you'll know all that, right? And then at that point, after those are sent out, I'll have like a 24 to 48 hour period, which I'll let you guys know when I send those out, during which time you can reach out to me if there were any errors. Oh, maybe you graded something wrong in the final, or maybe blah, 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 or, so you'll have a period to like challenge any grades. We can settle it, so we're both on the same page that, yes, this is your grade. This is what you got. And then after that, I will upload the grades officially. So that's kind of what to expect in the coming days. But I think I'll send out an email saying that anyway. But since we're here.
And then just to clarify with the uploading, I didn't know you could have the test open on your phone and the desktop at the same time.
Yeah,
Like
you can have it.
live.
You can have it open in multiple sources at the same time. It's just that only one source would be able to upload at a time.
Oh, okay. And it's whatever you open first.
It's whatever you open first.
Okay.
So I would log into Gradescope on your phone first, then you can log in on a desktop, and you upload directly from your phone, right? Like there should be, if you click on the upload button on your phone, you'll have options to take a new picture or select a picture from your gallery or blah, blah, blah. I would just take a new picture on the spot. You could take a picture and then save it to your gallery and upload from your gallery, but it'll still be pretty relatively quick even if you did that, I think. But I would just click on take a new picture and you take it right there. Other questions? As specific or as general as you want. So like I said, final combination of test 1 and test 2. It's about 16 problems total, including the bonus. So about 14-ish problems. In the final, and then the 2 bonus problems where I ask you integration by substitution or error between curves. which will be in the asynchronous lecture once I actually upload that. Of those two topics, I think the area between curves topic is easier. So if you only have time to look over one of those things, I'd probably look over that one. And then substitution afterwards. Substitution is something I don't think it's hard, but it is something that I think you'd probably want to practice quite a few problems just to get used to it. Which I mean, between now and Thursday, I think is enough time, but depends. You don't have to if you don't want to. It's bonus.
Will you have office hours? Because I saw like you had posted the test solutions. And I personally had a couple questions I wanted to go over when I was comparing my test.
Yeah. I will have office hours throughout the week. But as for the rest of today and like half of tomorrow, I'm pretty busy. So it will be tomorrow, Tuesday, around 4 p.m. and after. And you can just email me saying you want to meet with office hours and we try to find a time where we both can be there. But the next time where I'll have like free time to meet it's starting Tuesday afternoon.
If after the final, would we submit regrade requests for the final on Gradescope, or would we have to reach out to you directly for that?
No, like I will release the final just as any other test, and you can submit regrade requests for it. You might want to reach out to me additionally besides that, of course, in which case you're welcome to. And I would use email for that. So in about a week after the final, earlier if I can get it done, but I'll give myself a week. Yeah, the final exam will be released to you on Gradescope. You can look it over. If you don't agree with something, you send in a regrade request, as well as you'll know what final grade I intend to give you, which is going to be greater than or equal to the letter grade on your report card. Because like I said, I also take improvement into account. So your grade might earn you a B minus, but I might give you a B plus anyway. And what always happens is that, you know, I'd be in that situation where a student earned a B minus or maybe even a C plus, and I gave them a B plus, but they didn't read Jupyter. So they emailed me, "Professor, can you please give me like a B or a B plus?" And then I ended up having to answer the email, wasting time to say, well, I actually already gave you a B plus if you read it. So we shouldn't need to talk about this. So in Jupyter, you're going to see everything, like what I intend to give you and what you've earned. And what you've earned is already kind of more than you deserve because there's already a kind of curve built into the class. And then on top of that, if you improve, I might give you even a little bit extra. So at the end of the day, I think the grade is going to be more than fair. But of course, if there are still any issues, like I misgraded you or something, you should let me know. Yeah, so that's what I would say about that. Yeah, so I mean, if after this review, you guys think about some questions that you didn't ask, you're welcome to see me during office hours, but like I said, I'm not going to be available for those until like tomorrow afternoon. Okay. Any other questions, concerns? Yeah, and so the solutions for test 2 are already posted, so you can even look over those, including the bonus problems. You might be able to even figure out some of those, but yeah. Okay, that being said, I think we can wrap this up. All I would say is, you're welcome. All I would say is, the past is the past. We're only looking forward. So if you didn't do well in test 1, or oh, my quiz grade is so bad, like, don't worry about that. That's in the past. The only thing you can do now is to have a good final, right? So really focus on doing the best, because I am looking for improvement. If you messed up on something on test 1, but then you knocked it out of the park on the final, I'm going to be like, yeah, well, this person, they kind of learned their lesson, right? I'm not going to count test 1 that much against you. So don't bog yourself down worried about, oh, no, can I fail? My parents are going to some. No, just focus on moving forward, doing the best you can. Yeah, also remember when studying, as I mentioned, don't just look at the examples, but look at, like, I do a lot of writing about why I'm doing what I'm doing, and give you a lot of background information. So it's not just like, if you're practicing like limits and you're looking at L'Hopital's rule, you don't just want to see me go through the examples of me doing L'Hopital's rule. You should know, well, why is he using L'Hopital's rule? How is he using L'Hopital's rule? How did he put it into position to use L'Hopital's rule? Right? So these are things you should know, like these extra little concept things. Like, if I see a random limit, how should I approach it? If you're looking at things like optimization and related rates, know what the steps are, you know? So it's not just about going through the examples, because you can get confused by going through examples. In one sense, it'll seem like you know what's going on because one step follows logically from the other, and you're like, okay, well, I get it. But if you didn't have the steps in front of you and you had to come up with how to approach the problem in your own brain, it's a different thing. You know what I mean? And for that, you need the concepts, the steps, the things you look for, the approaches. And I gave you all these in the notes over the semester. So I would pay attention to those things first when studying, and then worry about doing a bunch of problems and looking through examples and things of that sort. Yeah, I think that's it. I think we can end there right now. Like I said, if you need to see me in office hours, you can do that starting, say, tomorrow afternoon. Other than that, I will say good luck, both in this class and with the rest of your classes. And I will see you guys in the next one. All right, ciao.